Test the performance of the window AC. Tools required: screwdriver, thermometer, air velocity meter, tongue tester, and a line tester. Equipment: window AC in running condition. Test the window AC performance.
Run the fan and observe any abnormal sound or rubbing noise. Check the incoming voltage. Start the compressor. Check the ambient temperature and room temperature. Take at least 3 readings at an interval of 10 to 15 minutes in different places in the room with a thermometer. Take grill temperature, evaporator air temperature. By velocity meter, check and note the air velocity at the grill. Check the condenser air outlet temperature and velocity. Check the condensate water drains.
Troubleshoot: compressor does not start, compressor trips frequently, poor cooling and gas shortage.
Servicing flow sequence for compressor does not start. Check the remote control. There may be a defect in the remote control. Check fuse. It could be fuse blown, high current drawn by compressor, low voltage. Check relay coil. It could be a relay coil burnt out or a high voltage. Check thermostat. The thermostat contact could be open. The thermostat feeler capillary could have been broken, or there could be just some mishandling. Check the overload protector. The overload protector contact could have opened. The overload protector could have tripped. Or it could be a high voltage. Or the overload protector is defective. Check the selector switch. The selector switch contacts may be open. A loose wire clips. A defective selector switch. Worn out knobs and screws. Check wiring. Either the wiring is burnt out or there could be loose connections. Check the compressor motor. The windings could have burnt out. Defective running capacitor. Servicing flow sequence for compressor trips frequently. Check the thermostat. The setting is in the low range. Thermal bulb location, or there could be just the control knob is loose. Check the overload protector. Correct rated value. Check the suction and discharge pressures. Check the wiring. Check for leaks. Check the condensing fan. Check the condenser fins. Servicing flow sequence, poor cooling and gas shortage. Check the refrigerant for contamination of the refrigerant, non-condensable gases with the refrigerant, improper evacuation of the service cylinder. Check in the evaporator. There could be a minute leak in the evaporator coil outlet. There could be a minute crack in the line. Check the suction line. There could be a minute leak in the suction line. This could be due to poor breezing, and there could be a minute crack in the suction line. Check refrigerant pressure. There could be insufficient refrigerant charge, or there could be an error in the gauge or a block in the charging line. Now that you have gone through these 12 exercises in this instructional presentation, you will be well aware of the problems that arise and how to solve them in the field. These are the main exercises in the repair and maintenance of window and split air conditioners. Study this carefully, for tomorrow you will actually face them in the field. When they do arise, you will be able to solve them with absolute ease.
Hello dear friends, today we shall discuss about repair and maintenance of refrigerators and deep freezers. Basically function wise, both the machines are same, only the required temperature ranges are different. So let us start with the common basic tools for this requirement.
These are the common basic tools for this purpose. Tube cutter. Small diameter annealed, soft copper tubes are used in most refrigeration work. Tube cutter is used to cut these tubes. It consists of V block against which the tube rests and an adjustable round blade of carbon steel which cuts the tube. Flaring tool. It is used for making up different types of flares of copper tubes. It has two parts: flaring bar, flaring yoke. Pipe bending tool, spring type. There are external coil spring bending tools where the external spring is designed to be used near the ends of tubes. Lever type. A lever type tube bender is used to form bends neatly and accurately without bucking the tubing. Pressure gauges. It is used to check the pressure of the refrigerant in refrigeration unit. There are high pressure and compound gauges. Thermometer. To check the temperature of any substance. Sling psychrometer. Relative humidity is measured by an instrument known as the sling psychrometer. This instrument consists of two ordinary thermometers securely fastened in a frame which is attached by chain. By means of this chain, the instrument can be rapidly whirled around so that it comes in contact with maximum amount of air. Around the bulb of one thermometer is a wick cloth which tampered with water when taking a reading. Halide torch. A thin carbon element is heated by hydrocarbon flame in the halide torch. The rubber tube in the torch extracts air on the element when flame burned. To find leak, this tube is slowly moved on outside joint of the system, fittings, and any slightest change in color of the flame shows the leakage. Gauge manifold. Two gauges are arranged for low and high pressures measurement. Either 3 or 4 flat connections for lines for the vacuum pump, refrigerant cylinder and appliance are to be tested. Flexible rubber charging line. It is flexible rubber lines already have connections on its ends. Flare fittings. Tongue tester. It is an instrument to check the voltage, resistance and drawing current by the appliance. Refrigerant cylinder. Vacuum pump. Recovery cylinder. Recovery unit. Pliers. Screwdriver. Spanner set. Ratchet wrench. Swagging tools. Swagging is a means of shaping copper tubing so that operation is accomplished with a punch type of screw type swaging tool. The tubing is clamped into the flaring block and a specially designed punch is hammered into the tubing, swaging or expanding the bend so that it will fit over the end of another piece of tubing. Pinching tools. It is used for sealing or closing the diameter of copper tubes. It consists of 2 bars forming jaws and holes of various sizes and are clamped together with using nuts and bolts. Swedging, flaring, pinching up and brazing technique. Swedging on copper tubing. Swedging permits 2 pieces of soft copper tubing of the same diameter to be joined together without the use of fittings. It is more convenient to solder one joint than make 2 flat connections. 2 types of swedging tools are commonly used: punch type and screw type. When punch type is used, the copper tubing is inserted into the correct hole size in the flaring block. Then a punch is inserted into the copper tubing and hammered down until it has entered the tubing the desired distance. When using the screw type tool, the tubing is placed over the expander. Squeezing the lever expands the tube to the proper size. Flaring. When connecting tubing to fittings, it is a common practice to flare the end of the tube and to use fittings designed to grip the flare for a vapor-tight seal. Pinching. Pinch-off tool is used whenever it is necessary to seal off copper's tubing so that no pressure can pass from one side of the pinch tube to the other. When isolation of parts of the refrigeration system is required, it is necessary to use pinching. Brazing. The end of the tubing after pinching is to be brazed. Mostly soft copper pipe tubes are used for piping purpose. We can make a joint by 2 ways: mechanical joints, brazed joint. For mechanical joints, flaring on the required end of the copper pipe is necessary. In this process, flaring tool is used. A flaring nut is placed on the pipe. Pipe should be free from rough edges. Choose the correct size of the hole and place the pipe properly. Tighten on the flaring bar hole. pipe diameter divided by 3. If pipe is quarter inch, that is 6 millimeter, position the pipe so that the end is at least more than 2 millimeter above the top of flaring block. Now fit the yoke on flaring block. Slowly screw it into the end of pipe. As it is shown, practically examine the flare. It should not be cracked. With the help of different sizes of flare fitting, we can make joints of all sizes and at all angles. Brace joints. To join two pieces of pipe of same size together, one must be made longer so that the others fit in. Making the end of a pipe longer is called swagging. You can see the swagging process. At the time of swagging, pressurize the yoke adapter slowly so that the end of the pipe does not expand abnormally. Now, fix another piece of pipe into the expanded portion of swaged pipe. With the help of blowtorch, propane, acetylene, blow lamp kerosene, and flux and bracing rod, we can make good leak-proof joint as it is showing. We must be careful at the time of brazing. Proper flux should be used. Touch the bracing rod on the joint after it gets red hot. What is refrigeration? Refrigeration contributes to the raising of living standards for the people of all lands. The application of refrigeration principle is limitless. The most common use is the preservation of food. The refrigeration process is a cycling system. Heat is picked up by the boiling refrigerant regardless of the shape of the evaporator. Heat which is rejected at the condenser may be carried away by air, water, the evaporation of water, or other means. Classification of refrigeration systems. In general, refrigerating systems fall according to use into the three groups. 1. High temperature systems, 2. Medium temperature systems, and 3. Low temperature systems. The high temperature refrigeration systems are used for air conditioning equipment where temperatures between 25 to 45 degrees Fahrenheit are needed. Medium temperature systems are used for food storage and other applications requiring temperatures between 25 and 0 degree Fahrenheit. Low temperature systems are for those applications requiring temperatures of 0 degree Fahrenheit or below. Heat energy. The capacity of a refrigeration system is determined by comparing its ability to absorb heat to that of the heat absorbed by the melting of 1 ton of ice in a 24-hour period of time. The refrigeration cycle works in 4 phases: compression, condensation, expansion, evaporation. It is refrigerating unit with open type reciprocating compressor. The machine has following parts: open type reciprocating compressor, electrical motor, condenser water circulating pump, evaporative type condenser, receiver, liquid indicator, hand jet off valve, thermostatic expansion valve, evaporator coil, suction line, accumulator, suction line attached with suction service valve, discharge line attached with discharge service valve. Voltmeter shows the line voltage 220 volt. Ampere meter shows the drawing current of the unit. High pressure, low pressure cutout with cutoff indicator. Water pump switches. Let us start the cycle from compressor. Compressor pumps the high pressure, high temperature vapors through discharge line to the condenser. Here, the refrigerant rejects the extra heat and liquefied. Liquefied high pressure, high temperature refrigerant. High temperature refrigerant liquid passes through thermostatic expansion valve. Thermal bulb of the thermostatic expansion valve is clamped with suction line. Here, the refrigerant liquid changes into low temperature, low pressure state and enters into the evaporator to produce the cooling after boiling at low temperature. Pressure cutout switch cut off the motor circuit cutout. If at any stage the pressure in the system gets lower or increases beyond safety limits, this switch cut off the motor circuit. Practically, it can be seen through an artificial situation. Now, switch off the condenser with circulating pump. The gauge show high discharge pressure after crossing a pre-adjusted limit. The high pressure cutout switch cut off the motor circuit. In the same way, the switch works at the low pressure conditions. This switch works as a safety device. Evaporative condenser uses both air and water as a condensing medium with sprinkle over the condenser coil. A fan installed on the top sucks the air from the bottom side. The air-water mixture absorbs the heat that results in liquefaction of the refrigerant. Water circulating pump regularize the water cycle. Conventional refrigerator. Conventional refrigerators are usually manufactured in different capacities and are normally equipped with hermetically sealed compressor and condenser units. The operation of refrigeration system works on vapor compression cycle system. The conventional refrigerator consists of the components like compressor, condenser, capillary tube, expansion device, evaporator, filter, and temperature control. Frost-free refrigerator. The operation of frost-free refrigerator systems work on vapor compression system. The frost-free refrigerator consists of compressor, condenser, filter, capillary tube expansion device, evaporator, evaporator motor, defrosting heater, temperature control, and timer. All frost-free refrigerators are provided automatic defrosting with a combination temperature defrost control. Freezers. There are two types of freezers. One is chest type and another one is upright freezer. Upright freezer. The basic refrigeration system is used on all upright freezers. The only variation being the use of fan, cool condenser located under the cabinet in a few models. Other upright freezers use a static condenser located on the back of the cabinet. All units are of conventional hermetically sealed design. Chest type freezer. Ice cream freezers are similar in most respect to chest type household freezers except for interior design. Refrigeration capacity. In normal practice, refrigeration capacity of equipment described in ton kilocalorie per hour or BTU per hour. In case of refrigerator, refrigerator capacity can also be referred by big volume. Again, volume can be converted in liters. Refrigeration capacity. Removal or absorption of 12,000 BTUs per hour or 3,024 kilocalorie per hour is equal to 1 ton of refrigeration. Standard models available in the market. Volumetric capacity. Conventional refrigerators 65 liters, 95 liters, 110 liters, 165 liters, 230 and 360 liters. Frost-free refrigerator 165, 230, 300 and 500 liters. It is a conversion of cubic feet into liters. Identification of refrigerator components. Mechanical parts. Compressor. The function of the compressor is to provide the necessary pumping action to the refrigerant. It draws cool refrigerant in through the suction line from the evaporator. It compresses it and discharges it into the condenser, where it is liquefied. The compressed gas has risen in temperature and pressure at the time of entering condenser. Suction line. The line through which refrigerant from evaporator to the compressor. This is toward the low pressure side of the system. Discharge line. The line between the compressor and the condenser is called discharge line, which is towards the high pressure of the system. Condenser. Condenser works as a door to discard the heat absorbed by the refrigerant at the evaporator, plus the heat added at the time of compression and the refrigerant gets liquefied. Filters, dryers. To sort out any foreign particle and moisture not allowed entering into the office of metering device. Capillary tube or metering device. It meters out the required amount of refrigerant to pick the heat from the evaporator. It consists of a long, small diameter copper tube as the liquid from the condenser is pushed through a small passageway. The friction between the refrigerant and tube causes pressure drop. Evaporator. Low pressure and low temperature refrigerant enters into the cooling coil to evaporate to produce low temperature and changes into vapors. Electrical parts. Compressor motor, relay ampere type, current type, overload protector, thermostat, cabinet light, door switch. Compressor motor windings. Any single-phase induction motor is not self-starting. It requires additional torque to rotate the rotor. To provide additional torque, starting winding is necessary. Single-phase compressor has two motor windings, the start winding and the run winding. These two windings are wired together in series inside the compressor motor stator. 3 wires are attached to these windings, one at each end and one at the common junction of the two windings. The pins are called the start, run and common pins terminal. The key fact you need to know is that the starting winding always has a higher resistance than the running winding. Check and identification of compressor windings. Check the continuity between terminal pins of compressor motor. After checking the resistance between these terminal pins, we found running winding resistance always less than starting winding. Starting winding resistance always higher than running winding. Summarily, we found that resistance between CNR running windings equal to 20 ohm, resistance between CNS starting winding equal to 40 ohm. Have we found resistance between SNR? Whole both windings remain in circuit equal to 60 ohms. By this exercise, we can search out the running starting terminals. Check short circuit of compressor motor or any other motor. Select one terminal of a motor and touch it with lead of ohm meter or continuity meter. Touch another lead of ohm meter, continuity meter with metal casing of the compressor or appliance you are checking. Check the continuity. Is there? Compressor motor is grounded. If there is no continuity, compressor motor is not grounded.
Starting relay is most important. The relay coil is connected in series with the running winding and connect points are connectors in series circuit with starting winding.
The relay allows the current to flow through the starting winding of the motor until the motor reaches about 2/3 of its rated speed at this stage. The current flowing through relay coil gets normal. Magnetic intensity goes down, not able to hold the weight of the plunger. Plunger gets down due to its weight, then disconnects or opens the contact point, results into open this starting winding circuit. To operate properly, the relays must be right size for the motor. Be sure it has the same electrical specifications as the original. Relay is an electrically operated switch used to disconnect the starting winding or starting capacitor from the circuit when the motor reaches at its rated speed. Types of relays. Current magnetic relay. Current relays are usually found on low torque, small horsepower motor. Current relay are sometimes called amperage relay, since it is the ampere draw on the circuit that operates the relay. Solid state relay. The solid state relay does not actually use a switch to take out the start winding. When the compressor is idle, the relay is cool and its resistance is very low. When the voltage is applied, the start and run windings are energized simultaneously and the compressor starts within a few seconds. The start winding current that is passing through the relay causes the relay to set quite hot. Potential type relay. Potential type starting relay is wired with a capacitor. Overload protector. An overload protector is connected in series of electric motor in any condition. When the motor draws more current than the normal, the OLP stops the motor operation. It consists of a bimetal disc and a resistor through which the current passes carried by the compressor. When too much current is being drawn, the resistor heats the bimetal and opens the contents. It will reset in 1 or 2 minutes and will try to start the compressor again. Check the continuity between the terminals of the thermostat. It should be in an on position at a constant range of temperature. Take the ball with ice and salt mixture, minus 15 degrees Celsius. Insert the sensing bulb into the ice properly. Take the temperature of ice. After a few seconds, the thermostat gets cut off. The ohm meter does not show any continuity in between the terminal of thermostat. Now, by turning the knob of thermostat, we check it at different temperature settings. In the same way, we can check the condition of door switch and light bulb with the help of continuity meter. With the help of ohm meter, continuity meter, thermostat on-off position can be checked. Check the continuity between the terminals of the thermostat. It should be in an on position at a constant range of temperature. Take the ball with ice and salt mixture, minus 15 degrees Celsius. Insert the sensing bulb into the ice properly. Take the temperature of ice. After a few seconds, the thermostat gets cut off. The ohm meter does not show any continuity in between the terminal of thermostat. Now, by turning the knob of thermostat, we check it at different temperature settings. In the same way, we can check the condition of door switch and light bulb with the help of continuity meter. With the help of ohm meter, continuity meter, thermostat on-off position can be checked. electrical part in frost-free refrigerator, cooling coil fan motor, timer switch, cooling coil defrost heater, cabinet coil heater, drip tray heater, cooling coil fan motor, cooling coil fan motor. It is shaded pole motor 220 volts. The motor circulates the temperature evenly in the freezer cabin. The motor is connected with the door switch when the cabin door is opened. The switch opens the contents and disconnects the motor when the door is closed. The contact start the supply motor, gets start rotate the fan and circulate the cool air. The fan motor is installed in front of cooling coil, tubes and fins type that is installed in between the walls of refrigerators. Timer switch. It is placed in a small PVC housing. A small motor is attached with teeth wheel. It is used to defrost ice in the freezer by controlling the operation of heater coil. On certain time interval, heater coil is installed with freezer coil. Timer switch work on clock mechanism when cooling coil gets over frost by time of 12 hours. The timer switch cut off the compressor supply and passes the supply to heater coil for a set time, say 15 minutes. Again the timer switches off the heater and compressor gets start. Wiring circuits of refrigerators and deep freezers.
Okay students, so let us revise what we have learned till now.
These are the common basic tools for this purpose. Swagging is a means of shaping copper tubing so that operation is accomplished with a punch type of screw type swedging tool. Swedging permits two pieces of soft copper tubing of the same diameter to be joined together without the use of fittings. Flaring. When connecting tubing to fittings, it is a common practice to flare the end of the tube. Pinch-off tool is used whenever it is necessary to seal off copper's tubing. We can make good leak-proof joint as it is showing. The refrigeration cycle works in 4 phases: compression, condensation, expansion, evaporation. The conventional refrigerator consists of the components like compressor, condenser, capillary tube, expansion device, evaporator, filter. The frost-free refrigerator consists of compressor, condenser, filter, capillary tube, expansion device, evaporator, evaporator motor, defrosting heater, temperature control, and timer. Refrigeration capacity. Removal or absorption of 12,000 BTUs per hour or 3024 kilocalorie per hour is equal to 1 ton of refrigeration. Compressor motor windings. Single-phase compressor has 2 motor windings, the start winding and the run winding. The relay allows the current to flow through the starting winding of the motor until the motor reaches about 2/3 of its rated speed. At this stage, the current flowing through relay coil gets normal, magnetic intensity goes down, not able to hold the weight of the plunger. Plunger gets down due to its weight, then disconnects or opens the contact point, results into open the starting winding circuit. refrigerants. Refrigerants are the heat transferring medium to transfer the unwanted heat in a refrigerating system. Picks up heat by evaporating at a low temperature and pressure and gives up heat by condensing at a higher temperature and pressure. Desirable properties of refrigerants. As desirable refrigerant should possess chemical, physical, and thermodynamic properties which permit its efficient application in refrigerating systems. The characteristics of a good refrigerant should have the following properties: low boiling point, high latent heat value, easy to liquefy at moderate pressure and temperature, operation on a positive pressure, mixes well with compressor oil, non-corrosive to metals, parts and motor winding insulation, other materials, not affected by moisture, not flammable and non-toxic, high dielectric strength, environmentally safe, no ozone depletion, no greenhouse effect. Global warming potential. CFCs and to a lesser degree HCFCs and HFCs also contribute to global warming. Apart from CFCs, gases like CO2, methane, sulfur, hexafluoride, SF6, nitrogen oxide and HFCs have been named as global warming gases absorb some of the solar radiation reflected from the Earth's surface and causes the Earth's surface temperature to rise, a phenomenon known as global warming. Global warming potential of substance is defined with reference to carbon dioxide, that is, mass of carbon dioxide needed to create the same level of global warming as 1 unit mass of substances. Ozone depletion potential. Refrigerants like CFCs and HCFCs cannot be vented into the atmosphere as they have ozone depletion and global warming potential. ODP equal to global depletion of O3 due to X divided by global depletion of O3 by same mass of CFC11. The ODP of CFC11 is 1 units by this definition. Recovery of refrigerants. Recovery of CFCs, HCFCs refrigerant from deep freezers and refrigerators is necessary for the cause of ODP and GWP. In case of faulty deep freezers, we have to recover R12 refrigerant in a separate cylinder. For this purpose, a separate recovery unit is required as shown. First, evacuate the recovery machine. Second, evacuate the recovery cylinder. And wait. Third, put the cylinder on a weighing machine and connect it with the recovery machine. And fourth, position the piercing valve on the process tube of the system and connect it with LP gauge port of manifold through a charging line. Position the another piercing valve on the liquid line HP side and connect it with HP port of the manifold. Now start the recovery machine. Open all the valves of manifold. Open the valve of recovery cylinder and keep it cool. And weigh the cylinder immediately. Close the valves. Check the weight. Whole of the refrigerant should be recovered. Servicing refrigerators. Try to install a refrigerator in a spacious room. Proper air circulation around the machine increases its efficiency and less energy consumption. Keep it away at least 6 inches from the wall. If the machine is with the open condenser installed on its backside, clean it with vacuum cleaner or air pressure once in season. Check the door gasket for any air leakage. Magnetic intensity should be proper. Electrical connections should be in tight position. Servicing. Deep freezers, external body. Paint should be in bright position to radiate the external heat. Servicing. Deep freezers, internal body. Storage of different types of eatables creates smell and fungus. Should be cleaned within 15 to 20 days. Due to moisture atmosphere inside the cabin can cause rusty surface. Take care of it. Condenser should be cleaned periodically. No dust is permissible. Electrical connection should be in tightened position. Checking leakage and raising. If a customer complains of no cooling into the machine, it can be a case of refrigerant leakage. To detect the leakage, following tools and material is required. High pressure gauge, nitrogen cylinder with double stage regulator and hose pipe, charging lines, bracing set, hand shut-off valve 1/4 by 1/4 inch, gauge manifold LP/HP gauges, adjustable spanner, ratchet key, refrigerant cylinder, soap water and brush.
Students, to show you in a better way, we have taken out the condensing unit so that you can see all the electrical and mechanical components with their working.
First of all, install a hand shut-off valve on the process tube charging line of the compressor with flare connections. On one end of hand shut-off valve, install a pressure gauge with rubber charging line. other end of the valve, connect a nitrogen cylinder having double stage pressure regulator. Release the nitrogen pressure from the cylinder valve slowly. Open the hand shut-off valve. Pressure starts to collect into the system. Fill the system with nitrogen 250 psi. Check the pressure in the gauge. Put soap solution on all suspected possible leaky joints. Detect the leaky joint. Mark it properly. Flush out the nitrogen from the system completely. Clean the leaky spot with file. Light the brazing torch, put goggles, apply brazing flux heat the joints till red heat connection. Now touch brazing rod, let it melt. Then the melted rod go full round. Stop brazing torch. Let the joint be cool. Put nitrogen pressure again and then check the leakage again. Stand the pressure for some time, it should not fall down. Now the system is fully leak-proof. Evacuation. Now on one part of gauge manifold LB gauge, install a rubber charging line and connect it with type hand shut-off valve that is fixed on compressor process tube, that is charging line. To avoid the purging action of charging lines at the time of refrigerant charging, we can take a precaution step here. Purging is a process of releasing some refrigerant into the atmosphere to avoid the line air to enter into the system. But it is a malpractice. Install a rubber charging line on the middle port of the manifold and other end with the refrigerant cylinder. Cylinder valve remain closed till evacuation. On the third port of the manifold HP gauge, install the vacuum pump with the help of another charging line. Open the valves of the manifold and switch on the vacuum pump. During evacuation, dehydrate the system. Both the gauges of manifold show vacuum up to 30 inches of mercury, 100 microns within some time. Now close the manifold valve where the vacuum pump line is attached. Stand still the system in vacuum position for at least 2 hours and check if there's any shortfall in vacuum position. It should remain standstill at the same reading.